will discuss, and what is our misconceptions we have now. We can correct our misconceptions in these seminars. We welcome all the participants. They have taken their time, even after hard work, the total week. And I would request, please keep silence and keep your questions ready. As soon as the his lecture is over, then we can start the question answer session. Thank you, sir. You have joined with us. Thank you. Thank you very much.
Thanks so much, Mr. Kargupta, for having me speak about ultra high performance composites and concrete today. It's a wonderful opportunity to go ahead and share information. Like you mentioned, maybe there are a lot of misconceptions in the industry, and that itself needs to be discussed. And you know, those kind of questions, I'm pretty sure there are too many questions around there that needs answers, and I'd be very happy today to discuss all those things. And if there is a need, although when I'll be talking, where if there is a need, there is a real need to have some kind of an explanation right in the middle, please feel free to. So,
Sir, now I would request Dr. Vineet Bajaj from NS ARCUS to introduce today's speaker. Vineet ji, please take over.
Thank you, Ramanji. Hello, sir. Very good evening and welcome to the Tech Talk by Concrete Engineers in association with NS ARCUS. It's my privilege to introduce today's eminent speaker. Brief about sir. Dr. Satish Jain has over 23 years of experience in structural engineering. He has been engaged in various design projects in India and US. He attained his Ph.D. and MS in structural engineering from Iowa State University, United States of America, and is a licensed structural engineer in both the countries, that is India and US. His expertise spans design with ultra high performance concrete, steel, pre-stressing and performance-based seismic design. Dr. Jain is credited with founding India's first commercial indigenous ultra high performance concrete premix manufacturing unit, and his current initiatives involve promoting the use of UHPC in India to design, material manufacturing, application development, training, R&D, and project management services. Dr. Jain is also the part of Indian Road Congress Subcommittee B 4.5 for guidelines on design and construction of UHPC road bridges. He is also the first chair of Indian Concrete Institute Technical Committee on UHPC. It is a privilege to have you, sir, and hopefully you'll be enlightening us with your wonderful lecture and clear the doubts of many budding engineers in this group. Thank you, sir.
Yeah. Thank you, Mr. Bajaj, for your kind words. So, is it time to start? Shall I?
Yes, sir. Yes, sir. Please.
Okay. Okay. Great. So again, welcome everybody this evening. It's wonderful to be here. Like I said before, I would love to share a lot of things today, and I'll go ahead and start presenting my screen and talking. So let's do that. So I hope my screen is visible right now.
Yes, sir, it is visible.
Okay, perfect. So, yes, if you see at the right top, we are talking about ultra high performance UHPC, and I have kind of, just put that word out there, composites out there. And there's a reason why I did that today. So when we talk, when we have this tech talk, specifically on concrete, how this composite words really fits in there, and why it has a little bit of a different meaning, and the attributes that are going to change the way things look out in the future. So we're going to talk about that a bit. I'm not going to delve about this particular slide, but we are a 100% Indian technology based company. I think somebody's mic is on, so there's a disturbance out there. Yeah. And we are Mumbai based over here. So UHPC India is private limited is a fully 100% Indian owned company, and it is Indian based. Yes. And to showcase India's very, very first project. So UHPC is not something that's waiting out there. The very, very first project in the country uh, was not a bridge project, was not an industrial project. It was a very, very simple school project, and a school project done by ISKCON, just north of Mumbai. And there was UHPC used on the roof level or the terrace level of the project. And I will delve upon that a little bit more. But it has been just over a couple of years now, February 2021. So just over a couple of years that this project has been completed, and it has paved the way for use of more and more UHPC in the country. So let me start with this, and I just want to do this because there are so many questions, in the past seminars, etc., that always come up. What is the cost of UHPC? What is the cost of UHPC? And for a lot of people, it's quite surprising. So let me first define UHPC, right? There are few words in it. Ultra signifies super good, or super strong, something of that sort. And it is a fibrous composite, so there is going to be a lot of fiber components. Now what kind, whether steel fibers, whether some kind of a polymer fiber, we can discuss that as well. And why I say composite out here is because this kind of a material, when used in construction, specifically construction, really does not contain any coarse aggregate. So it's more like a mortar, and with huge amount of fibers in it, and that's why it's more like a fibrous composite. And when you look at the material itself, it's not just that it behaves like concrete. Okay, so, and it's not that it behaves like steel, but it has a property right in between concrete and structural steel. There are certain portions of the material that behaves more like concrete, and there are certain portions, certain properties of the material that behave more like structural steel. And so it's a whole new material there you look at. And I will emphasize that by giving some rough figures of the cost out there and allow you to think. Okay, because what happens if I say concrete is about 7,000 rupees a cubic meter? uh, you know, at the start of the day, a couple of years back, and even prior to that, when I was talking about UHPC a little bit, people used to ask me, what's the cost of UHPC? Is it 10,000 rupees, 12,000 rupees? And when they would hear that it's closer to ₹1,00,000 a cubic meter, they would say, uh-oh, that material is not for the country. It's not going to work. It's never going to work. You forget about this. But one has to understand, why are we comparing concrete to a cementitious fibrous composite? When I say concrete, I mean normal concrete out there, or a little bit of a high strength concrete out there. We are either elevating those performances, okay, and taking it to a different level and allowing it to be called as a fibrous composite, right? Look at structural steel below. I put on the cost. Nobody really talks of structural steel in terms of cubic meters cost, right? But I'm still putting it out there. About 7 lakh rupees a cubic meter, or 90 rupees as designed, as partial fabricated. Erection cost I have not put in there. If you start putting erection cost, it's going to go all the way to, I don't know today what it is, maybe about 120 rupees a kilogram on major projects. But 7,000 to 1 lakh rupees is over, close to 15 times. And between UHPC and structural steel, it's a 7 times cost increment again. But you and I and everybody here present know that structural steel is widely used across the country in variety of projects, whether it is industrial projects, whether it is infrastructure projects, and also in building projects, especially commercial building projects. A lot of structural steel is used. So if concrete is 7,000 rupees and steel is 100 times costlier, How does it work? Well, the material has different properties, correct? So the design philosophies are different. The way you utilize it or conceptualize the structure is a bit different. And you come up with solutions which at the end of the day, the concrete and structural steel solutions are plus or minus within like 10% or so, depending on the kind of project it is, right? So that's why I keep saying don't look at UHPC with respect to a 1 lakh rupees a cubic meter. It has a lot to offer because the design mechanisms are different. The way it should be applied, it should be different. Where you're going to use it, how you're going to use it is going to be different. And I just want you to take through this figure out there, right? Although the cost wise, UHPC and steel may be, a 7 times difference in cubic meters, but it's just a 2 times difference when it comes to, kilogram cost, right? Concrete has a density, or UHPC has a density closer to 2,500, and steel has a density closer to 7,800. And so it's a ratio of 2. So what's more valid? And that's what we are going to see. And there is a slide that I have a little bit later during the presentation, which is going to show you that difference where it really matters, right? So remember that there's a 2 times difference in terms of kilogram cost of UHPC and structural steel, right? So now we'll move forward because I wanted, the team here that is present and that's listening to first grasp these numbers and understand these numbers. I could have gone ahead and left it out for the last slide or left it out to just answer it later on, and then the perspective is just lost. And I can talk all good about UHPC, but let's bring this money perspective up front over here, which will allow us to see how we're going to use UHPC. Aha. So the first thing I'm going to tell you, see, ductile is a material. Left side, you see, ductile is a material, out of Europe. It's a product. It's a UHPC product, and this slide is from one of my good friends from ductile. So look at the comparison, right over here. Reinforced concrete. There's a solution out for a beam. Pre-stressed concrete. There's a solution out. Suddenly, when you come to steel, the section size has reduced dramatically, correct? There you have a steel size. But moving a little bit more left, look at UHPC. The size is not too different. The size is not too different. And the weights are not too different too. Now, this is in pounds per linear foot, but you look, steel is at about 75 pounds per linear foot, whereas UHPC is at 94 pounds a linear foot. The difference is not twice, but steel costs twice. So can we look at structures that can now be done using this ultra high performance fibrous composite that is much more economical than structural steel? That's a possibility, and that's what I really want to tell you. That the perspective has to change, the look has to change. As to the numbers don't matter, 1 lakh, 7 lakh don't matter, but what matters is how you're going to engineer or how you're going to use your UHPC. So why are we talking about this material? I'll show you. I mean, there's a lot of ease of construction. Okay, we're talking about a fibrous material that can flow in easily, that can be used very easily. We're talking about speed of construction. You're going to see that. The longevity of construction. When I say longevity, the service life and the life cycle costs. We'll talk about that too. And of course, the economics of the final product. That's where it comes to. Aesthetics. That's another thing to remember, right? If you're going to be doing a lot of architectural projects, or, building projects, aesthetics does matter, correct? And today, actually, I just shouldn't limit it to building projects. Even bridges, there are lot of nice bridges that are coming up, where the designs are also prescribed in terms of aesthetics by the architects. So aesthetics is playing a huge role, and we'll see a bridge example out in France, which shows something really great. And at end of the day, I've highlighted it in green. At UHPC is green. It is green. You will see when I talk about all those things that I've just mentioned above that it is a green material. And at the end of the day, you need ingenuity in structural design. And I'll tell you that upfront, otherwise I'll forget it during the talk, that as part of the Indian Concrete Institute's what we are doing, the UHPC technical subcommittee, what we are doing is we are planning to come out, or we are working on coming out with about a 50 example manual on how to design using UHPC. So these are going to be small examples, maybe half a page, 1 page, maximum 2 page examples, which are going to be there, and about 50 examples of designing beams, columns, other kind of things, uh, repair, repair related design, strengthening design, which will really allow the structural engineers in our country to start becoming more familiar and coming at ease with using ultra high performance concrete. So here it is. The material itself is powder, 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 just mix of powders. You're going to be using, of course, you're going to be using cement, you're going to be using pozzolans out there, you're going to be using, something like a microsilica out there, and you're going to be using fine sand. You are not going to be using coarse aggregate at all when it comes to construction grade UHPC, right? So it's going to be a powder material, looks very fine, plus a huge amount of steel fibers, right? So the steel fibers are going to be about 2% by volume. And just to give it some perspective, that is about 156 kilograms a cubic meter. And look at the size of the fibers, about 0.2 mm by 13 mm length. So they are very, very fine, and there are lakhs and lakhs of fibers in 1 cubic meter, right? And another thing shown down below is, well, it flows very nicely. In fact, I have a video, and I am going to play that video for you, right? So there's the video. I'm just going to tone down the volume, and I'm going to show you this. See, this is a small flow test. So you're not going to use a huge cone to test out UHPC flow. Okay, so there is a ASTM code. ASTM C1856-17, 1856-17, which is for the entire testing and characteristics of UHPC flow, not just flow, all the material characteristics, and the flow comes from there, and you can see that this table, it's maximum about close to about 275 or so, yeah, 24 centimeters, so 240 mm of flow on this particular mix. Typically you're going to have anywhere from 190 to 240, 250 mm of flow. And once you have this kind of a thing, it's just so easy to place UHPC, extremely easy to place UHPC. There's another UHPC that is used, and we are going to come to that. That's called UHPC overlay, where you need a little bit of a thixotropic mix, which just doesn't flow off. It is workable, but just doesn't flow off. So we'll come to that. Yeah. So to give you some ideas, on the left side, I'm showing, comparative, compressive strengths in the range of 140 to 220 MPa. And why do I limit to 220 MPa? That's in general, that's what you're going to get. You definitely can go to 250 also. And there are certain ways and means that you can achieve 350 MPa, 400 MPa. So there are ways to do that, but that is outside the realm of normal use of UHPC in construction. So that's about the compressive strength. Elastic modulus, okay, very, very high, generally very high, 50 gigapascals or 50,000 megapascals. Third thing, low creep coefficient, about one with normal curing, right? So concrete has a creep coefficient of 2, whereas UHPC, you can get about 1. So what's the advantage of these three things that I just spoke about? See, when it comes to long span, you can put a whole lot of pre-stressing in it and still keep going longer, right? Because the more the compressive strength, you can put in more pre-stressing. And you can come up with, long spans have deflection related issues. That's where the E and the R, the elastic modulus helps, and also the low creeps helps with the long-term deflections. So this is a great recipe when it comes to, doing long span structures with UHPC. And you can do a lot of short span also, right? But it's a great recipe to put pre-stressing in as well. Uh, top right, top right. Talk about tensile properties. You see, when we talk of normal concrete is brittle. We all know that, right? So we talk about strength. So there are many times that people have asked me, what is the flexural strength of UHPC, or what is the tensile strength of UHPC? And I have a simple answer, to them, which I'm showing that over here, is it is not the strength that matters. It is the ductility or the toughness that matters. And that difference is shown over here. So normal concrete will probably go up to, 5 or 6 megapascals in tension, and then you'll have a brittle failure. But look at UHPC. UHPC is going to go to 9, 10, even, if you add a little bit more fiber, it can go up to 12, 13 megapascals as well in tension. But beyond that, you get this ductility, you get this strain hardening, right? And you can go all the way to 0.005 or 0.006 strain before strain softening starts, and it still keeps going. I mean, if I were to continue this chart, it'll go up to like 0.015 strain. So this strain hardening matters. This early strain hardening matters. That is what gives UHPC the energy dissipation characteristics, right? Which means that in this zone, when cracking happens, there is not just one crack or two cracks. There are multitudes of cracks that are going to happen, and those cracks are going to be extremely fine. So fine that they may be, you can call them impermeable, cracks as well, because most of them are not visible through naked eye in these early stages until that one cracks gives way, and that crack starts opening in the strain softening area. But that's the beauty, the toughness, the tensile toughness is huge. And this is what you can use. This is what you can use in the design. So down below is the design, the flexural design of beams. You can see below the neutral axis, when you design a reinforced concrete beam, what do you have? Above the neutral axis, you have a parabolic compressive curve. And below the neutral axis, you have nothing except for the steel or the pre-stressing, right? Here, because of its ultra high strength, you have a triangular compression curve above the neutral axis. And below the neutral axis, you take this strain hardening portion from top and you put it down below, and that gives you a great flexural capacity. Okay, now that can be used as part of the design, and therefore you can really reduce your rebar quantities enormously in UHPC elements, right? So that's a big advantage that comes by reduction of these reinforcing steel. Another thing is, shear. I mean, I don't know if I have a slide on shear or not, but this ductility that you have allows for huge amount of shear resistance in UHPC. And if it doesn't come later, I'll explain it to you a little bit more. But I hope the last 2 3 slides have kind of, we are diving into the technicalities of how UHPC is really different than concrete, how it may be closer to steel in terms of design, and how possibly we can come up with some economical solutions. Let me talk why it is called performance. Why not just ultra high strength concrete, correct? It's called ultra high performance concrete because there are so many durability performance criteria that UHPC is great at, really great at. And here is a quick example. Well, before I talk of the example, let's talk about the longevity. We have a material over here that can not only give you 100-year service life, it's possible to get 100-year maintenance-free service life. Now, just that changes the entire dynamics, right? Because 100-year maintenance-free means that you're not going to be spending any more money on your project. Once it's done, it's done. Yes, there's an early cost to it, probably, but life cycle, if it's a government bridge, nobody has to come and spend anything on it later on. And let me compare this chart. You see this yellow line, this is concrete. And this is just a relative comparison, right? That's concrete. Green is, high strength, high performance concrete. And if blue, you can still see that's UHPC. That's how low, amount of oxygen permeability it has, or chloride ion penetration depth it has. Even water permeability is way too low. The corrosion rate is like next to negligible. Carbonation depths are low. Even freeze thaw, for areas in colder regions, etc. Concrete has the standard test. You check with 300 cycles of freeze thaw in concrete, and you typically lose about, they check it against the relative dynamic modulus, and you lose about 50% of relative dynamic modulus in concrete in freeze thaw, after 300 cycles of freeze thaw in a standard test. But when it comes to UHPC, even at 600 cycles, it retains either 98, 99, or even 100% of your relative dynamic modulus. So it's a great material even to use in colder regions as an overlay for military applications, etc. That's a great property of UHPC. So just to give you an example, if you were to be looking at a RCPT value, because a lot of you are, maybe very, very well aware that concrete, when you do a rapid chloride penetration test and you're allowing the charge to go through, the regular concrete could be anywhere like 3,000, 4,000 coulombs. It could allow M25, M30 or something like that. We are going to a very, very high, extremely high performance concrete. Again, you're looking at numbers closer to 1,000 coulombs or something like that. But in general, UHPC will have less than 250 coulombs of charge passing through it. That's how tight it is. The particle packing of UHPC is extremely tight. And if I forget to tell you this later, concrete is brittle and explosive when you do compression test on very, very high strength concrete. But UHPC, you no longer have that because of the presence of the steel fibers. It's just showing you what I just talked about. You see the issues. These bridges are having all kind of cracks on their webs. And what kind of a bridge has cracks right at their, in the webs at the ends, at the support, near the support? I mean, that just sounds fishy. You typically don't have a long span flexural beam, and you have a long span structural frame, and you never get a diagonal crack like that. But that's amazing to see these. And you see all kind of retrofit measures that have been done over here. In fact, this bridge is, in the Thane region of Mumbai, undergoing repairs right now, and it has all kind of problems, right? Uh, but what you need is a continuous flow of money to maintain your bridges. Let me give you an idea of what kind of money we are talking about in today's term. You see, India has uh, right now there are so many infrastructure projects that are going on. Look at, we have this annual budget allocation for more. That number in during last year was a lakh and 18,000 crore rupees, for the entire month. So we are talking of even roads and bridges and running the entire administration and everything. Assume even 15% is going towards new bridges, right? About 17,000 or 18,000 crores, which means during the life cycle you're going to be spending twice and about 36,000 crore rupees every year. That's taxpayers' money, right? And you're adding that kind, and it's just the MOTS budget I'm talking about. States have their own budgets, uh, for highways and all kind of projects, infrastructure projects. There's amount of money that's going into rehabilitation projects or repair projects or strengthening projects of infrastructure. The maintenance free cycle that I was talking about. See, you build something, it deteriorates, you strengthen it, it deteriorates again, you add some load capacity, strengthen it more, deteriorates again. UHPC, once you use it, it's a one-time solution. Let's just put it, it's a one-time solution. Absolutely. I think as engineers, we need to understand it sometimes more than just asking for a direct cost and comparing it to a regular concrete cost, that UHPC delivers a lifelong solution to you, right? That's something we should keep in mind. And I was talking about architectural bridges, aesthetics in engineering, and UHPC can really deliver that. See, this is a bridge in southern France in Montpellier, and you can see such sleek columns or sleek piers coming out of UHPC. Even the girders are in UHPC, but wonderful. And these are all precast. They just have post tension within it. Just 4 months to complete. Look at that. Just 4 months to complete. And I'll show you. It's just that post tensioning coming through and connecting with the girder, pier cap. Left side, that's how the girder looks. It's a nice inverted T girder, then connecting with the slab above. And right at the pier foundation, all you have a rocker bearing. You have a rocker bearing connection. Simple, straightforward solutions that can be brought about with UHPC. Beautiful solution as well. I'm also going to show you, this is short spans, right? A 16-meter span. Uh, it looks like a pie, therefore it's called a pie girder, right? So these are just pie girders that are made up. So the slab and the web and the bottom flange, everything is connected, just precast on site, put right next to each other. They're just put right to next to each other and just connected. They're connected or stitched together. Again, the stitching is done with cast in place UHPC. Okay, so cast in place UHPC is used for stitching them together. And there you have your bridge girder. Don't have to do anything. Don't have to put any more supports, etc. Cast the slabs, do this and that. The solutions come about. I'm going to show you another solution. Waffle deck bridge. Here the girder is not out of UHPC. Here the deck is out of UHPC. So if you look at the deck, you see it's a very thin waffle deck, just 65 thick slab, and the ribs are a total of 200 deep, and a single rebar actually in the rib. Every rib has just one rebar in it. Uh, and these are just connected to each other. Let me show you some connections. These are precast, put on top of the girders. And the waffle deck to waffle deck is again connected with UHPC, stitched together with UHPC and along with the girder on one side, and in the transverse direction you also have the stitching out there. But it's a very simple and straightforward connection. use of UHPC. Imagine just going back over here, how much lighter this is to your conventional 250 to 280 to 300 thick deck slabs that you're putting on top of your bridges. The reduction in weight, it's just about one third. It's just one third weight of a typical deck. Your seismic weights come down in your construction. One has to think about those kind of things. Really has to think about those kind of things if you're going to come up with sleeker solutions. And while I talk about joints, let me tell you that it's not just infrastructure. We can talk about buildings as well. You see this. This is of course a bridge project, and they have these precast decks on the right side where my mouse is. You can see that these are precast decks, concrete decks, but they are all jointed together or stitched together using UHPC. And UHPC is so strong that this joint is far superior to your parent element, right? And so you can see the face of the joint. On the left-hand side, you can see what a conventional joint would look at versus what a UHPC joint would look as. And the UHPC joints are sleeker just because of the robust characteristics of the material. So to give you a general example, your bond strength, right? Your bond strength between concrete and rebar, you need about close to 40 to 50 times the diameter of rebar to develop your rebar, right? In concrete, in UHPC, you just need 15 times the bar diameter. That's how really good the bond strength is. And so you get sleeker joints. You can come up with, completely new construction techniques, right? You don't concrete right on top of your precast members because those are not positively connected. They're just butting against each other. Now you have a new solution. You can have rebar coming out and you join them together. You don't have to put that 75 concrete or concrete over that or screed over that deck. Why do you want to increase your dead weights? You have a proper diaphragm now. The precast elements are forming a proper diaphragm. So there are things that need to change. Our outlook needs to change when it comes to utilizing these materials and seeing the benefit of it. It's not just about the material cost. It's just saved you on a 20-story tower. This has just saved you 75 of concrete over the entire floors. It has reduced your cost of construction, timeline of construction, right? So that's a thought process. Same thing with UHPC, prefab girders. How many times do we see that there are possibilities? There are possibilities. I'm not saying that it can be done in every situation. That there are possibilities that certain segmental bridges, could be converted into just, a span could be just divided into maybe 3 segments or something like that instead of having n number of segments. It's possible. It's possible. Not every time, but it's possible. And that's where you can again have a sleeker joint and you can use UHPC to join. And believe me, this has been seismically tested with cyclic loadings, right? Missouri S&T. Missouri S&T is a university in the US, in the state of Missouri. That's where full-scale testing of UHPC stitch joints have been done. Correct? So again, faster construction, lesser false work, you can keep moving ahead. That's the beauty of UHPC. Expansion joints, how many times you have expansion joints? You need to have them, correct? You need to have expansion joints. But water leaking through it, what's the problem? Everything rots. Everything rots. And what do you have at the end of the day? your bearings deteriorate faster, and you need solution. You need solution out there, maintenance solution. So UHPC can, there's a great solution with UHPC, where left side you see it's a conventional, expansion joint. In the middle is a UHPC link slab, and what you will see is the expansion, the lateral expansion, is moved from the top to the bottom at the bearings, and the rotation that happens at the bearings is moved to the top. That's where the UHPC is. Okay, a little link slab that is put, partial jointed. That's where UHPC is put. So that's where the rotation happens. UHPC has great ductility, so it has rotational capacity. So now you can appreciate the fact that there is no moisture or water penetration that can happen through your expansion joint. This is an expansion joint. We are not saying that we are eliminating the expansion joint. We are just, interchanging the mechanisms of rotation and translation by just changing their locations. But then we are avoiding the water ingress. It is a very simple thing that can be done on projects. All right. Rapid strength gain. So, okay, just to bring this to perspective, there's no one kind of UHPC. You can make several kinds of UHPC, but one of the most common kinds that gets sold or so is a rapid strength development. Right, in one day you will get about 50 MPa plus, in 3 days you will get 90, 100 MPa, and there's so much that you can do with that rapid development of strength. You can open up traffic faster. You can, get things moving really good. Bonding, excellent bonding. Already spoke about it. Crack resistant, and of course, strength. We already talked about it. Advantages of using UHPC as a joint fill material. Prefab elements again. Aha. So this was one slide I was mentioning earlier. I will again show this. This is precast piles, happening a little bit in Canada and US. UHPC precast piles are going down. I want to show you just one thing. A UHPC pile, precast pile, is weighing about 61 pounds per foot over here, whereas a steel pile is about 57 pounds. And believe me, steel H piles are preferred in the Midwest or the central region of the US. They're just way faster. But the weights are so close together. And what did I tell you about the cost? UHPC is half as costly per kilogram than structural steel. You see how much you could be saving now? Tremendous. Of course, you're not saving 50%. You need to have a formwork for your pile. You need to add some pre-stressing, etc. But definitely, you can save about 20-25%. You are going to be saving. That's a benefit. That's a benefit that you bring about. So, amazing UHPC. India, unfortunately, is a huge market for repair and strengthening. I mean, I say unfortunately because things are not lasting. Bridges are built for 80, 100 years and are falling apart in 15 years. You have to go ahead and strengthen them up. Similar is the case with buildings, unfortunately. So UHPC can come as a great boon, great material for repair and rehab. So first example I'll talk about is here's a slide where they're showing UHPC, also called as UHPFRC, right? Ultra high performance fiber reinforced composite or fiber reinforced concrete. You see on the left side, a simple layer, maybe about a 40 layer of UHPC is put over the top of a brick deck, correct? And this can be put on new decks. This can be put on existing decks. But once you do that, you're not only arresting the moisture intrusion and safeguarding the concrete below, but the material itself is so highly abrasion resistant that you may not need any kind of wearing coat, right? So that's the beauty of UHPC. So this is a very general. You see, it's a very nice roughening. Okay, I'm going to talk about the roughening process a bit, but you need to have a pretty good roughening process. On the right side, and you may or may not require the rebar, but this is a typical strengthening project where even rebar has been put. And well, I think the left side was about 30 in this particular project, and the right side was about 50 or so of UHPC. But it's a reinforced UHPC used for strengthening one of the bridges in Switzerland. Uh, yeah, it's a viaduct in Switzerland, Chillon viaduct in Switzerland, where UHPC was put in, and a couple of inches of UHPC was put in. So you get advantage in terms of freeze and thaw, very low permeability, again, abrasion resistance, I spoke about it, crack resistance, excellent strength and stiffness. You mention it, it's there, correct? And you just get excellent behavior throughout the life cycle. Here is something that I saw in person. This was in 2019 in New York, Albany, New York. See, UHPC is just mixed on site in a bit of a high energy pan mixer. So it's not just a simple pan mixer. There's a bit of a high energy pan mixer that they've used. See the roughening process. This concrete, underlying concrete was roughened so nicely. You could use hydrodemolition. You can use a combination of milling and hydrodemolition. But you need a good roughened surface for good bonding purpose, right? And then this was a simple project, so a very simple, truss screed vibrator was used over here. And immediately after putting that, they are putting a curing compound or spraying a curing compound after screeding it. Curing compound is put so that evaporation can be arrested. A little bit of an industrial grade slab strengthening. It's not more of strengthening, it's again abrasion, abrasion resistance. So here was a project where we supplied some material to it. Was a little bitty of a material, but they had a huge cable drums over here, and this bobbin, after the entire winding was complete, the wire was there, about 20 metric ton bobbin would just fall down on the floor, and they had some steel plate over here, but then it would move ahead on the concrete floor, and every 6 months they had to keep redoing. Every 6 months they had to keep redoing. So here was a solution that we were able to offer, where a little portion was still roughened up and UHPC was poured over it and cured. Side repairs of girders, that's in Switzerland. So, I mean, all I'm showing is, what kind of things can we really use UHPC? India can be a big user of UHPC in the near future. I can attest to that because, see, UHPC as such started out in Europe, Denmark, really speaking, and then the French took over. Made a lot of UHPC, spread it around the world. It came to US and Canada, uh, Europe, of course, Germany, Switzerland, and other countries were using it. On the other side of the world, Japan picked up very nicely, Australia picked up, Malaysia picked up, China being one of the last countries. Maybe about 7-8 years they picked up. Today China is the biggest both manufacturer and also it is the biggest user of UHPC combined, everybody in the world. That's how fast they've grown in the use of UHPC. And in India, we are the last major country to really adopt UHPC, right? We're the last major country. It could have been adopted earlier, but we are last. So it doesn't matter. The time is here now. More repair, you see these are precast segments which are put right next to each other for a deck. and that's your weathering coat, and there's moisture intrusion through that, and it's started, creating problems to the concrete down below. All they did it is, if you look on the right hand side, they opened up these joints. Right, they opened up these joints and they poured UHPC in it. A simple solution. This was in Florida. This is a Venezuelan, project where marine piles, you know, they were repaired using UHPC, just 30 jacket, called it good. This is Canada, where they used UHPC 100 cover, and this is a railway bridge, right? That was a railway bridge that was used. In fact, there's another example of a railway bridge in Canada where they did seismic jacketing, seismic strengthening. So that was done. You can increase punching shear capacities in slabs if there was a reason to believe that your flat slab is not designed for punching shear, or there is, it needs some additional strength. UHPC could be used to enhance it quite a bit. And also steel girder strengthening could be done. Could be done by putting some UHPC at the ends, if you wanted to take care of those corroded portions. One of the other quick uses of UHPC is, let's say you have a normal concrete, U girder. You have a U girder, but there was some poor consolidation or something. Now this is again from Florida. You put UHPC in that area. In a single day, you get your 50-60 MPa. You're good to go. So it can be erected. So there's no time lag over there. You're probably losing at max a day, but then things can be taken care of. That's that seismic retrofit Canadian project. It's a pedestrian work. It's a different kind of work. This is in Switzerland. That was done. More pedestrian bridges around the world, but let me tell you, if you go to the bottom right, that's one of my favorites. It's simple, just looks like a bent steel plate, right? That's what it looks like. You can come up with really, really nice and thin pedestrian bridges as well, apart from that. So we spoke about design shear strength, right? Design shear strength, excellent, at least 10 MPa. Without rebar, you get 10 MPa design shear strength. So that's an amazing thing. Most of the time, the girders, etc., that you're going to be doing, 90% of the time, you're not going to be using any shear rebar. There may be some right at the ends, but otherwise, you're not going to do that. We already spoke about the bond strength, so which gives a development length of just about 15 times the diameter. We spoke about 24 hours, 3-day strengths. Already spoke about that. I'll show you a little rehab project that we did. There was a column extension that was supposed to be done, and there wasn't sufficient rebar length available for lapping. Okay, so that wasn't there. So what do? You will have to do a lot of epoxy rebars. You have to anchor them down with epoxy, add those extra rebars and do that. Here was a solution we gave. We said, because of its great development length, you just, in the bottom areas, you put UHPC, your strength would be developed, and then you can start continuing with your normal concrete. So you can do that. I'm going to show you some architectural, masterpieces as well. This is a railway station in Montpellier, France. Very nice. You can see long cantilevers. That entire roof is out of UHPC. There's all precast UHPCs out there, right? That's the formwork. Beautiful formwork. Wonderful work done by the engineer who made the formwork. But nice vaults were made out of UHPC for this project. Columns, designer columns. You can see all those columns standing up. Very nice designer columns, all just post-tension and connected to the steel roof and the foundation below. So in this project, only columns were out of UHPC. Nice balconies. Yeah, stepped staircases and these very nice shaped balconies that could be just brought in and fixed to the project. Facade work, architectural facade, beautiful. This was also in Montpellier. I took this pic. It was just wonderful to see this facade. Such nice grace, and blue skies up there, with clouds. It was just wonderful. So, few things, we want to talk about busting myths. There's a lot of wrong information also spreading around, and I think we should shed some light on it. Number one, okay, I hear people saying that UHPC can only be done in a precast facility. Oh no, 90% of the work around the world with UHPC is done on the site, right? And they are just made on the site. So you probably have UHPC premixes coming in, small bags, big bags, whatever. You're gonna have a, ice patcher, or you can just weigh your ice, steel fibers, and a mixer, some kind of a mixer, right? Some decent mixer. You can mix on site, you can pour it on site. That's how easy it is. So no, it's not necessary that UHPC elements have to be precast on site. You can even precast it on site. Another thing, UHPC cannot be cast in place. Who said that? That's something that we hear. UHPC can be cast in place. Here you will see, this is in Mumbai itself. UHPC is being poured by a bucket. So the right side is just a story or two above the ground level, but on the left side, what you see, this is all the way up at the 13th level where 19-meter spans were put. So it can be cast in place. And I'm going to show you a video over here where UHPC has been pumped. You'll see this video. Now this is a joisted, ribbed deck, 13th and 14th level on top of a building in Mumbai. These floors were added. You see, UHPC here was actually mixed in a transit mixer. It was mixed in a transit mixer. It was not coming out from a plant. So the bags were put in, it was mixed. It just flows out very nicely. It's going into a pump, and you see it has come out. And you can see that in a video over here. The temperatures are low, about 25, 26 degrees Celsius. It's just so nicely coming out. You can imagine this UHPC has huge amount of steel fibers in it, the microfine steel fibers, and it's still flowing out consistently. That's how beautiful it is. You just don't have to do anything. Right? That's at the end of the day. Yeah. And then there is another myth saying that UHPC has to be steam cured. Again, I'll tell you, 90%, 95% of the UHPC, there is no need to steam cure it. You can just use your normal curing. You can use your curing compound. Left side, you see, these are small UHPC beams, about 8.5 meters long, 20, yeah. So 30 days continuously UHPC was poured, about 84 beams were put together, and you can see the strength that was achieved. We took cubes every day, right? Site mixing, normal water curing, about mean strength of 186 MPa with a standard deviation of about 8 MPa. And the right side material was used for a little bit of an overlay near a station in Mumbai. Again, 3 day strength achieved was about 117 MPa on this particular project. So you can make UHPC. Another myth is that you have to pour UHPC within 10 minutes, 20 minutes, 30 minutes. No. You can devise your own UHPC. You can have it workable for a long time. Just excuse me 1 second. I got to put this medicine in my eye. And so UHPC, you just need what? You need retention admixtures, right? You can retain your UHPC as long as you want, 2 hours, 4 hours, 6 hours. It's up to you. what you're devising, correct? So all that's possible, all that's really possible. So these kind of myths or misinformation that's spread around, one has to understand that at the end of the day, it is a material. Yes, it's the quality control has to be high, but it is still a material which you can play with and you can create your own, right? On the construction, I just want to show one little slide over here, that on a job site, if you're getting a jumbo bag, you just have a mixer that needs to be put on top of a telescopic stand. You put crushed ice on it and add the steel fibers, and then you can have a bucket down below, or you can have a pump down below through which UHPC can be moved into wherever it needs to be placed. So on site, it could be a very, very simple mechanism. There it shows. Yeah, so the bucket's there, and the bucket will take it to the beam and just pour it into the beam. So I'll just show you some other things. This project I wanted to talk to you about specifically. I showed this project up front, but you see, the owner wanted. What was the solution? What was the problem that we solved using UHPC on this project? This was a school that was put together, and the spans were about 7 meters. Okay, so there were two spans of 7 meters, total 14 meters. And when it reached the top story, the owner called us and said that, well, at the top we want a 14-meter span. Now it was just a 2 to 3 story. This thing, the structural engineer said, I cannot have, huge spans because it will increase the load on my exterior columns, because the columns are just designed, this was a small building. The column doesn't have the capacity to carry a lot more. The foundations doesn't have a capacity to carry a lot more. So this, and they wanted the roof to be in concrete as well, right? Because they wanted to hold dinners, etc., or some other activities at the terrace level. So it's not like you could have just put a metal deck on top and some steel truss and called it good, right? It had to be concrete. So here we came up with an idea of this kind of an inverted T, a little bit of an I, very thin. This was post tensioned, 14 meters long, and you wouldn't believe it, the total weight was down by 30% compared to the original. Sorry, go back to it. Compared to the original two span of 7 meters, the weight on the end columns came down by 30% by using this UHPC solution. See, the post tensioning was done, and this is how they were picked up and put together right on the top. This is the first project of India, Govardhan Eco Village. There's another project wherein hollow UHPC beams were made, and that was more for the heating or the HVAC units, for the heating and ventilation, air conditioning units out there. So there was some extra design work that went into that because of putting the openings in. Sprinkler lines were put in, and here too you can see one of the first floors, the beams being picked up very nicely, and brought around 84 beams cast of that project. I'll just show you some of them. This is the 19-meter spans. This was cast in place at the 13th level. So casting was done very easily. The UHPC in this case was just made down, put into your wheelbarrows, and through the construction lift, it went all the way up. So there were like 7 or 8 wheelbarrows in line, and it was just going up, coming down, going up, coming down, and it was just poured with wheelbarrows. Your regular construction means and methods, right? This is a bungalow that we did in Tirupati. The owner wanted to make it out of UHPC, so here ripped slabs were used again. So ripped slab was cast in place, but the steps, we made these stairs out of UHPC. It was precast on site and then put together. You can see that over here. And you can see the ripped slabs looking really nice thereafter. I'll show you this as well. So here's a project where, the owner is a hotelier, and he wanted to, there's a 12-story building coming up, right? But the first story, the ground floor, is a banquet hall, and they wanted to open it up last October, like 2022, for the wedding season. And they were already late. So the banquet hall has a 9-meter height. Okay, it's pretty high. So if you're going, and huge spans, 16-meter spans. So if you're going to be, doing your regular false work or shuttering and propping and everything, and then putting, concrete and post tensioning it up right at the top, and they were not going to meet the schedule. So we brought in a thought process. We said, what if, I'll just start over here. I said, what if we have precast UHPC beams, precast on your site, and also we precast the RC slabs, 4 meters by 5 meters, pieces on the ground, and then we pull them all up and we put it together and we stitch it together with UHPC. So I'm just going to show you this and I'll narrate it as this goes. So this is the beam that is being put together. You see, hardly any rebar over there. For some composite action with the slab, there is rebar right at the top. The post tensioning ducts, which are here. That's the form work. You can see the slabs. These are RC slabs, okay, not UHPC slabs. Only the beams was UHPC. That's of course the UHPC coming out of the truck again. You can see that. And there's the concrete. So regular contractor doing it, right? We help the contractors understand what to do, what not to do, whether it is UHPC and all. You can see these slabs and see post tensioning was done down below itself at the ground level, right? And the beam was then pulled up, slabs were then pulled up one by one, they were put together. And here's the icing on the cake. All this erection and the stitching, etc., was all done only in 2.5 days time. The owner was able to open this banquet hall 7 days before he could complete all his interiors work in time and open it up. So that's the joint that you see. That's the UHPC joint out there. So looking forward, if you want to talk about it, UHPC, look at UHPC to add value. Look at UHPC to solve problems. Also, you can look at UHPC as an alternate to structural steel. We just have solved a problem, and this project is coming up where 800 mm by 1600 mm, columns, thick columns, gravity loaded columns in M80 concrete, we were able to replace with just 750 by 750 UHPC columns. Okay, there were 5 of these, and the construction work has just started on this one. But imagine 800 by 1600 columns of M80 to replace this with 750 by 750 in a commercial building, in a department store. That's adding value to the customers, to the owners, right? Gives you space. It also helps the structure, right? But it reduces the space, or increases the space. Gives you something to look forward to. That's what I'm saying. The new generation of engineering possibilities is here. We need not replace all the concrete. We need not replace all the structural steel. UHPC can find a place of its own somewhere in the middle. It can also work as composites with concrete and with structural steel, and can create new possibilities. So yeah, that's where I am. So I'm just going to say thank you. I'm going to stop sharing so that I can see, your faces and come up with answering questions. Thank you very much. Yeah.
Thank you, sir. It was a nice presentation. So I hope all the doubts regarding the UHPC technology have been cleared. We have some questions in the chat box. If you can answer them.
Oh, okay. Yeah, there are several. Can UHPC be used in marine, river, waterborne structures, tunnel structures? So the answer is yes, because UHPC is not one kind. You have to develop different kind of UHPCs in marine environment. And also for tunneling applications, something like a sprayable UHPC could be developed, or for precasting. Tunnel precast liners can also be done. Yes. So 3D technology, yes, UHPC has just about started in the outside world. Some UHPC is being used in 3D, not so much. Another question from Mr. Chinnaradi is, for UHPC, what is the minimum what is the minimum water cementitious content? So I would say, UHPC, uh, again, it can be in the range of 0.15 to 0.2, 0.21. Okay, so there's a broad range out there. 0.15 is on the lesser side, 0.21 is slightly on the higher side. Uh, would UHPC use any kind of microsilica, silica, fume? Uh, so you can make your own UHPC. Yeah, it could. Microsilicas help with really pushing up the strengths and all of that. So, and it helps with the durability aspect as well, because it's just so fine. So yeah. How do you control deflections and lateral buckling? I mean, that's more of a design problem, right? Material, you have material characteristics. Control deflections, I already spoke about in terms of moment of inertia, lower creep, higher strength. You can put more pre-stressing. And then lateral buckling, you will have to do simple buckling analyses or stability analyses. uh, I can definitely tell you that, because the sizes are slightly more better than structural steel, the buckling issues, are not going to be as predominant as they are there in the steel members. So, yeah, thank you, Mr. Rajay, for your comment. What would be the disadvantage you think of UHPC? Well, uh, simple thing. I'm not thinking of UHPC to replace. UHPC shall be replacing all the concrete or all the structural steel, an entire structure. 100% of the building made with UHPC. No, that's not going to happen. So that's what I think. How temperature control in UHPC? Again, iced water is being used. That is one thing, and then retarders are being used, so that can be done. Mr. Appasaheb, I think he joined in late. We're talking about cost of UHPC, and that is somewhere about a lakh a cubic meter, but that's not the right way to look at it. I cannot explain it again over here. We need to go through all the questions. More questions on costing. Well, you just cannot compare, a lakh rupees a cubic meter to 7,000 rupees for concrete. The engineering mechanics and methodologies are different. You need to look at it as structural steel, which is even more expensive, right? Just reiterating that. What are the challenges yet that the UHPC is encountering in the Indian market? So yes, couple of challenges, two, three. Yes, one, that the design community does not know how to design, and they are a little bit afraid of taking the risk. Second thing is, we need more trained technicians and engineers and professionals on the field who know how to mix and place UHPC. So it's going to happen over time. Uh, a good UHPC is a particle packing. Okay, so Mr. Ravi Shankar, standardization, precision in formulation and pouring. Yeah, I mean, there's UHPC is going to become the norm. It is going to find its own place. out there. So how helpful to slip form and shear wall technology? Well, that again, you can use it to slip form. We have to use a different kind of a accelerating agent out there so that you have those quick early strengths, very early strengths, so that the slip form can keep moving. But you don't want to use, you want to change all your shear walls to UHPC at the moment. um, Minimum cementitious content and minimum grade to design the UHPC, Mr. Mahesh Gangadhar has asked. So cementitious content, cementitious material, that's a good question, not the cement. So yeah, you can say anywhere from cementatious, total cementatious could be anywhere from 600 to 1,000, 1,100. It's high kgs per cubic meter. Minimum grade, well, like to say, in India, French code right now is being used. The Indian codes are going to come up. We're working on it. 150 MPa is something that is put in line that could be used. What are the design codes? So currently, if you want to design, you can use the French code for UHPC. You can use the French Swiss code for UHPC for design, and for material testing, you can use ASTM C 1856-17. Indian codes are going to come up sooner. They're going to come up. The recommendations are going to come up. We are working on that. Okay, any special curing requirements? Like I said, nothing. You can do water curing. You can use curing compound. It's good enough. RCPT of UHPC, how to find RCPT of, because steel fibers are used? Good question. But even if you use steel fibers, the steel fibers are discontinuous, so it doesn't form a battery, you know. So you need not be afraid. You can do it with fibers. You can do it without steel fibers, right? You can check your RCPTs. Uh, Code of UHPC I just spoke about. Side effects to using by mistake high quantity in concrete or having any setting problem. Side effects, I don't know. You're not going to use it in concrete, right? You're going to use it as its own material, and then you might do a composite connection with concrete or something like that. Uh, Compared to, again, there's a cost question. We've spoken about it right before, that it's a different material. It's a composite. It's somewhere between concrete and steel. So you can assume right now about 42 rupees a kg inclusive of steel fibers, and close to about a lakh rupees, maybe something like that. But you got to use your design appropriately. What does cement contain? Well, what does UHPC contain? All the pozzolans, etc. There's a lot of literature available out there. We can go through that in detail. If I wanted to use it in my upcoming project, how can I gain further insight? Well, you can read a lot more. There are a lot of YouTube information which is available, and as far as, if interested in our material, you can connect with our office for that. Okay. Kerry William, which material that makes up the UHPC is 10 times than the traditional mixed design? Okay, so it is, see, the particle packing is very tight. That's very important to understand. Good quality super plasticizers that can disperse like microsilica very nicely, and cement very nicely. So good super plasticizers are very important. Also, you know, the right kind of microsilica, etc. So you will have to try your own, what's available in your area, and you have to keep it up. But particle packing really makes a huge difference out there. You can test, like I said, RCPT. You can check it because you don't have a continuity of the steel fibers. They're discontinuous. But I'll also tell you at the same point of time that the ASTM C 1856-17 is okay with you testing the RCPT without the steel fiber also. Okay. ठीक है. How can we replace the batching plant in Pan India? Not too difficult. It could be done. I mean, all those can be discussed. How can I get the specification of steel fibers? So it's all available on the web, but it's less than 0.2 diameter. That's what you want. About 13 length. Aspect ratios above 60 diameter. Length to diameter. Tensile strength about 2800 MPa. That's what you need. So uh, that's there. And then I think we're done with the questions in the question box. I think there's a hand raised by Mr. Riga Ravi Kumar and Mushrif Khan. Mr. Ravi Kumar, can you ask your question, please? Okay. I'm not sure if Mr. Ravi Kumar is. Mr. Mushrif Khan, you have a question? You raised your hands. Okay. There's another question. Can blended cement, PPC, PSC composite complements UHPC performance instead of? You can. So Mr. Siddharth Bhatt has asked a good question. See, if you want to come up with a UHPC of your own, you can. You'll have to just do some work. You can use all kind of cements to come up. All applications deserve a UHPC of their own. So you can definitely come up with that. Can we test any NDT? Can we test any NDT? Can we do any NDT test conducting in UHPC structure? You could. It's a cementitious material. You could do your NDT test pretty well. Yeah. I think we have covered all the questions now.
Yes, sir. Thank you, sir. I would request participants if anybody has some questions, so they can ask.
Yeah, I have one question.
Yes.
Yes.
Sir,
Yes.
while designing UHPC,
Correct.
what would be the qualitatively, what would be the confidence level we can keep designing USP? That means when we want to get some target mean strength, what would be the Z score and standard deviations?
Haha. Yeah. So what I would say is, if you're targeting a 150 strength, if in your labs you're able to achieve about 165 or something like that, that'd be great. Like I said, I mean, we have checked like on one of the projects I had mentioned that we had poured UHPC 30 days continuously, had n number of cubes, and the standard deviation we achieved over there was about 8 MPa, and the mean was about 186 MPa, although it was designed to 150. But that is what we got.
So it is same as 95% confidential level.
You can say that. You can say that. The thing is that it's such a.
My point is, sir, is there any need to increase the Z score from 1.65 to any value higher side?
You could. I mean, that's something that I would love to discuss with you over here, because what we try to do is not go by the regular mixed design procedures,
Yeah.
with that, right? And there is nothing like when it comes to UHPC, you don't say this is a 150 UHPC, this is a 155 UHPC, this is a 160 UHPC. No, it's very difficult, because what happens is, due to the variety of raw materials in it, um, if if uh, if all the raw materials come on the negative side, then
Yes.
too you should achieve your 150 out there. So you could have a very nice range between 150 MPa and 180 MPa out there. If you have the best of all raw materials coming during a certain mix, then it's fine. But that range is going to be there. I mean, for some other kind of application where targeting 200 MPa, and I mean we have that already for an application, but then we are trying to make sure that we are, the means of all the tests that are happening in the laboratory are achieving 230 out there, so that 200 is definitely achieved on the site. Not that 195 is going to make any difference, but if somebody goes ahead on site and doesn't know, and they reject, it's supposed to be 200 MPa, and if it comes out to be 196 mean on the site, it's easy for somebody to reject it on site without understanding the consequence that a cubic meter of UHPC could be so expensive. You're not you're not rejecting a 5, 6, 7,000 rupees concrete. You're rejecting a lakh of cubic meter of concrete over there. So yes, continuous testing in the lab, continuous quality control from batch to batch of the cement that's coming in, that becomes very, very important. And to have that range a little bit high, although we have got 8 MPa standard deviation, but not necessarily. You might want to keep it, you know, lowest order as 150, so that it is always above that.
And what would be the mold size for getting compressive strength?
Oh,
It is
okay.
it is usually 150, 150 by 150. No.
No, no, great question. So in the labs, I can tell you, and actually also in the fields, but I don't want to promote that. But in the labs, you can always go with 50 by 50 by 50 cubes. Okay. And once you are at a certain point, okay, this is what it is for me. You can use 100 You can use 100 cubes for your final testing, and then on the site you can keep 100 If you want to use your standard cement cubes, like 70, the 70 cubes, those are also fine. The 100 cubes give you the same result. Um, in the US, they use cylinders which are 3 inches by 6 inches for UHPC. So that's about like 75 by 150. So the 100 cubes match exactly as the 75 by 100 75 by 150 cylinders. So that's a very benchmark solution out there on the field for you. Also, the rate of testing could be increased to 1 MPa per second for UHPC.
1 MPa per second
1 MPa per second.
is a pace rate,
Yeah, I mean the loading rate.
loading rate.
Right, right.
Okay. Any questions from anybody? Any more questions? Can we conclude?
No, yeah, I have one question. Can I ask?
Yeah,
Sure.
yeah, sure.
Yeah,
Please.
no, if you see in the normal concrete, we are check for the deflection as per IRC 112. When it
Mhm.
comes to UHPC,
Yes.
how are we going to check this? Check for deflection, because you are having a very sleek models, and whatever the dimensions you are getting is very small. And if you see, and you are trying to, when it is a compressive strength of 150, 220, obviously will go for a bigger spans. So, and your dimensions are small, or does it suffice those deflection criteria?
Oh yes, absolutely. So the checking is no different. If you're asking about the checking methodologies, there would be no difference, right? Because your modulus of elasticity is higher. You are going to put more pre-stressing in, and your creep is going to be lower, right? So that automatically helps, and it definitely helps. You can do that. In fact, we have developed in-house uh, you know design softwares for UHPC designs, and which in fact calculates your strains per the loading also, like you're doing, let's say, designing a composite beam. So when you have your self weight, or when the post tensioning comes or pre-stressing comes, and then your additional dead weight comes in terms of the wet weight of concrete, and after that your finishing weathering coat comes. So you can do all kind of a analyses and work and come out with the strains and then integrate your strains to come up with the deflections and work it out. And for that matter, we have certain long span beams that we have already done and worked them out, and they're perfectly good. No real long term deflections, not a problem. You can really make them work.
Oh. And one more query I have. Is it like our UHPC is tough or brittle material than the normal?
Oh, it's ductile. The material itself is quite ductile, very ductile.
Oh,
Has huge amount of fibers, so it's very ductile.
Sir, I have one question.
Sure.
Yeah, when we are being considering for use in beam and we are replacing some structural beam with this UHPC beam,
Mhm.
any cost comparison? If MS structural member replaced with UHPC, which will one is the economical one? Any?
Aha.
Uh,
So that you will have to start at your conceptual level, right?
yeah.
So at the conceptual level, you're going to lay your things out. जैसे आप steel structure design करते हैं, you you think differently, right? While designing a steel structure, you
Right.
think a little bit differently than how you think concrete. So that's how you will have to lay it out with your thought process, and then come up with the economics of the things. आप दो चार बार try करेंगे, you will be able to achieve the right kind of layouts. The first time is always going to be difficult, but the next time and the next time becomes easier for you to really come up with a viable solution.
But is it an economical over the structural? Still, what is your experience?
It can be. So आप ऐसा नहीं बोल सकते कि मैं ना अभी एक 100 मीटर का स्पैन बना दूंगा एंड मैं यूएचपीसी डाल दूंगा तो it will help. But what you have to see is whether whether that 100-meter span or whatever it is, how are you putting it together, right? For example, you're looking at a replacing an steel arch bridge using UHPC. So the entire thought process was different with respect to the constructability, right? Removal of false work, etc. was there. Then to the way the UHPC girders were put together, there was no additional need to put any top deck. So the flanges were made in such a way that the top deck is part of the entire thing. So you have to conceptually
Okay.
sit down and start,
Okay.
thinking what you're going to be doing with that.
We have to look at the whole structure as a project instead of considering the separate member.
Exactly. With steel also you do that, right? Steel is so much lighter on a commercial building. So your columns are lighter, your foundation is lighter, your earthquake loads are lower, and at the end of the day, the project cost comes out to be lower. Correct?
Yeah. Right.
Lower, or it may be plus or minus 10% within the concrete building, depending on what. So that's how UHPC will also come out to be. You just have to look at it as a project. Absolutely.
Oh, thank you.
Sure. So it looks like I think we're now somebody has asked UHPC material is powder form or liquid. Excuse me. Somebody's just asked UHPC material is powder form or liquid form. So, well, you can send it out from a RMC plant and it will be in wet form. If you send out a bag of it, it will be in dry form and then you mix it on the site. So it can be either after. And somebody has asked what are the tests required before and after. So I mean, after is easier, right? Your compression test and durability tests, etc., or your flexural tests that are going to be there. What are the initial tests? Initial tests are all about in your laboratory. You're going to make sure that whatever raw materials are coming in, and those raw materials are satisfying all your requirements as such, quality requirements of the raw material before you mix them together. Okay.
Sir, can you show your slide contact number so that we can take a screenshot? The last slide, mail ID and contact number.
Oh, the mail ID and things. 1 second. The last slide. Hold on. Let me see if the last slide or the first slide. One of the two, right? Yeah, you can take a pic of it. Is that good? Let me know.
Yes, it's good.
Yes,
Yeah, sure.
Yeah.
Okay.
Okay, thank you.
so I hope, sir, we should wind up the session now.
Sure.
It was a very interesting presentation, and a lot of doubts have been cleared about this new technology. And as the topic suggests that future of engineering in India will be UHPC, that's 100% correct, because the applications you have shown, so all those applications are problem areas, actually more problem areas in our engineering fraternity. So there is now a material which is a very user friendly material for these all problems, so that I hope this will gain momentum in our country. So now I would request Kargupta sir to propose a vote of thanks, please. Kargupta sir, please.
Yeah, thanks, Raman. It was a very nice, detailed, informative presentations regarding everything, where it has been used, what is its property. It is a mix without any coarse aggregate, Sir also told, and rich in rich in fibers, so that we can get a very big toughness. The toughness is the main, what I feel, toughness is the main property which is giving, which makes it high performance. And it also has some good compressive strength, high elastic modulus, low creep coefficients, and good tensile strength, I mean flexural strength, and good toughness. And in respect of durability, it's very fine. I have seen that oxygen permeability and water permeability is almost nil compared to the other concretes. And these two parameters, when it is nil, then corrosion of reinforcement may be considered as nil, because corrosion of reinforcement requires both oxygen and water as electrolyte. So when oxygen and water is absent, so there is no chances of corrosion. Chloride ion penetration depth is also low, so that chloride cannot come in the vicinity of the steel surfaces. So freeze-thaw cycle is very high. So in all respect, shear resistance is very high. So in all respect, UHPC is not only high strength, it is a very highly durable matrix. So thank you, sir. You have given a lot of idea, lot of insight in what is UHPC. And I would thank to all the participants that for patient hearings. And in future also, we will be doing such kind of informative webinar. Thank you very much, sir. Thank you.
Thank you. Thank you for having me here. Thanks. Yeah.
Thank you, sir. And we hope such sessions we will repeat also on such topics with you. And also, we would like to thank today's our associates, NS ARCUS, who have supported us for today's Tech Talk. So thank you, Vineet ji, on behalf of that. He is present on behalf of NS ARCUS. So thank you, sir.
Thank you.
Thank you very much, sir. Thank you, everyone. Thank you. Good night.
Thank you, sir.
Good night.
Thank you, sir.
Good night.
Thank you, sir.